irrational numbers. Please check out our earlier videos on number system as well as rational and irrational numbers. I want to recap the concepts with a diagram which we have shown before in our videos mentioned above. This diagram displays the connection between different types of numbers. In this video, we're going to talk about irrational numbers in detail. We have seen before all decimal numbers which are non-terminating and non-repeating are called irrational numbers. Let's take the value of the popular number pi. The value of pi is not a finite number. The decimal places keep going indefinitely. I have just chosen to display only a few of those decimals here. So the value of pi here is 3.1415926535899793 ... It's obvious from the above the value of pi is a non-terminating and non-repeating number. So pi is an irrational number. However, we use pi all the time for calculations on circular, cylindrical, and many other shapes. If pi is not a number whose decimal value terminates, then how do we use pi in our calculations? We cannot make that into a fraction either, because irrational numbers cannot be converted to a fraction. And we know that. Well, the way we use pi for calculations is by taking an approximate value of pi. Approximation of pi. As you have seen before, the value of pi equals 3.141592 ... We approximate the value for most day-to-day calculations to either 3.14 or more commonly as a fraction 22/7. But we know this value is only approximation and not the exact value of pi. Let's see an example where pi is used for calculation. If the diameter of a circle is 14 centimeter, what is its circumference? We'll use the formula for calculating the circumference of the circle given its diameter. Circumference of the circle equals pi d, where d is the diameter. Using the approximate value of pi as 22/7, circumference of the circle equals 22/7 times 14. Let's take out the common factor of 7. So 1 times 7 is 7, 2 times 7 is 14. So we put 1 at the denominator and 2 at the numerator for 14. This simplifies to 22 times 2, which is 44 centimeters. We should realize that this value is only an approximation for calculating the perimeter or circumference of a circle. If we measure the circumference of a circle whose diameter is 14 centimeters more precisely, we'll see the value to be different than what we have computed here. Let's see some more irrational numbers. The radicals are irrational when they are radicals of non-perfect powers. We'll see examples with just square roots of imperfect squares as well as cube roots of imperfect cubes. Let's look at the square root of 2 and cube root of 6. Square root of 2 equals 1.414213,562 ... Cube root of 6 equals 1.817120,592 ... Both these radicals are irrational. However, when we use them in calculations, square root of 2 is approximated to 1.414, square root of 3 is approximated to 1.732, and so on. Similarly, cube root of 6 is approximated to 1.817. Let's look at one more famous irrational number, the golden ratio. This ratio is called as golden mean, the divine proportion, and even the most beautiful number in the universe. This is represented by the Greek alphabet phi. Phi equals 1.618033,988 ... It's approximated to 1.618. And you may wonder why it's such a special number. There are a lot of things in this world that follow the golden ratio. In other words, nature produces golden ratio and it appears magical. We'll just see a few examples. The list is very long, by the way. Measure the length from your head to toe and then divide that by the length from belly button to toe, and you will see it's in golden ratio of 1.618. Several other ratios of human body lengths provide the same golden ratio. In the Fibonacci series of 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, and so on, Two successive numbers after the 13th term in the series will always be in golden ratio. There are many more, but our objective is not to learn about golden ratio, but to say that this ratio is an irrational number. As we said before, all irrational numbers are approximated based on the level of precision we need in our calculations. That's all we have on irrational numbers. Thank you for watching. See you soon.